Hello, welcome to the series of videos on C++ programming language. I am Brijendra. In this video, we will study about single dimension arrays. So what is the plan for this video? First, basic concept of the array, then basic syntax, followed by declaration and initialization statements for single dimensional arrays, then indexing, it helps you access the elements, followed by character arrays and their properties, and a few working programs. In 2022, I made some programs by making use of Visual C++. I will share that also. And some programs I made long back using Turbo C++ 3.0. I will share that also. So this is the plan for this video. So what is an array? An array is a collection of items of same data type where in contiguous memory space. And one thing more, the entire collection is referred to by a single name. So for example, here we have an array of 4 items of same data type. And now suppose these items are of type int, integer, and size of an int is 4 bytes. In that case, first item would occupy first 4 bytes. So byte number 0, 1, 2, 3. So first item, first int would be stored in these, okay, these 4 bytes. Next, that is item 1, like a second integer, that would be stored in next 4 bytes, and so on. So last item 3 would occupy last 4 bytes, byte number 12, 13, 14, 15. And all these 4 integers together would be referred to as by an array A. Now order of these items may be different in memory depending on the endianness, but about that we will discuss in some other video. Now let us see syntax, how to initialize and declare an initialize array. So first requirement is data type. What is the data type of the array to be declared? Then its name, then opening square bracket, size, closing square bracket, and semicolon. So values are not assigned. In the next type of a syntax, data type, name, size, and opening closing brackets here, then assignment operator, opening brace and here closing brace, followed by semicolon, and between these two braces list of values separated by comma. Third one is data type, name, square brackets, nothing in between. Then assignment operator, then the same thing as previously written, list of values within pair of braces and followed by semicolon. So what is the difference? Here we had size mentioned, okay, whereas here compiler will deduce how many items would be stored, so how much amount of space is to be reserved. So few points to note. What is the data type? It can be any built-in data type like int, float, char, unsigned char, etc. Or it can be user defined like struct for a structure or union, etc. The name, it has to be any legal name, but it has to be unique in this scope. We did talk about scope in one of the previous videos. Size means how many elements of this data type would be there. How many elements? And it has to be an integer constant, positive integer constant greater than 0. So if you want to write 5.0 for size, claiming that 5.0 is nothing but an integer, no. Its internal representation would be a floating point number or real number. So it has to be exactly an integer and its value has to be greater than 0 at compile time. It means when your program is being compiled, at that point of time value or size must be known. Then list of values, these values are separated by comma. So comma is a delimiter. And one thing more, this size and list of values must be identical. And the last point is all values must be of same data type. This is the property of array. All values must be of same data type. Now examples. What have I done here? Ages is an array of 5 integer elements. Initial values are not assigned, so maybe arbitrary or it will be compiler dependent. Then float temperatures 4. Temperatures is an array of 4 floating point numbers. Okay, and the last one is char, str, and this one abcd. So str is a character array of size 5 with 4 characters and last 5th character being null character. So here first 4 characters would be abcd, so they will occupy 4 bytes, and last character would be null character, which is nothing but null, capital L, capital letters, or within single quotes \0. I have made few programs, so let us see some working programs. What we have done here is we have declared an array of size 4 of type int, that is integer. So it will reserve space for 4 integers, and the name of the array is A1. Okay. Now here what we have done here is we are trying to access the first integer. Okay, so index number, this is referred to as index value. So index value would be from 0 through 3, that is first index number would be 0 because counting begins from 0, then 1 followed by 2 and then 3, that is 1 less than the size of the array. If you exceed this limit, what will be the result? It is compiler dependent. And second thing, all these 4 integers, none of them have been initialized with any value by us. So compiler will assign arbitrary value. It will assign arbitrary values. What will be those values? We don't know. So it is supposed to print some arbitrary value in response to this. In this statement, we have initialized the first integer as 10. So its value has been initialized. So in response to this statement here, it should print 10. In the next statement, we have initialized all the 3 values. This is another array A2 of size type int. So we have supplied 3 values separated by comma, absolutely no problem. So this for loop would print, is supposed to print 3 integer values 10, 20, 30, etc. Here I have used the other form of initialization, declaration and initialization. So F1 is of type float, so it will reserve space for 3 floating point numbers. So compiler deduces from the number of values and the size of F1. Okay, so this while loop would print 3 values contiguously. So let us execute this. Now you can see here, in response to this, it is printing some arbitrary value here, but here it is printing for this 10, and again for A1 it is printing this some arbitrary value which we did not supply. In response to this, you can see 10, 20 and 30, it is printing 10, 20 and 30. In response to this, it is printing the values which we have assigned. Okay, so 1.1, 2.2 and 3.3. Okay, so let us rerun it and check. Now you can see here what it has done. It has done here, it is printing some arbitrary value here, sorry, here, and then here for A1 it is printing this. So again it has printed different values. So we should not rely on what values compiler will assign. What we have done here is declared one array A1 of size 3 of type character, and we have initialized all these 3 locations with individual values. First one is capital A, then capital B, then null character. So what it is supposed to print here is, in response to this, is capital A, and for next capital B and nothing else. Okay, fine, no problem. Here this is a special way of printing the character strings only, character arrays only for character. It does not apply for other data types, arrays of other data types, and name of an array is its address. So what it is supposed to do here is it will start from the first index location and it will keep on printing until unless it encounters null character. Okay, so what it is supposed to print here is capital A followed by capital B again, and then it should stop at null character. So absolutely no problem. Now here we have declared another array of size 10, name is A2, data type is char, that is character. We can initialize these locations in any order. So what we have done here is ninth location, that is index number 8, has been initialized with null character. Last location, that is index number 9, has been initialized with capital Z. Of course it should not be printed because before that we have null character. Then first location capital A, next location I have skipped, so compiler should fill it with arbitrary value. What will be the value? We don't know. Next index number 2 capital C. So here what should it do? What it should do, it should start printing from capital A, then arbitrary, then capital C, and followed by arbitrary characters, and it should stop at index number 8, ninth location, because here it is null character. So let us see what does it do by executing it. I can see here first it has printed these two characters, absolutely no problem, capital A, capital B. Okay. Now here also it starts printing from capital A, terminates at null character, no problem. But what it has done here is it starts printing from capital A and stops there. What does it mean? It means at second index location position, that is index number 1, it has assumed that it is null character. So it means it is specific to the character arrays in G++, which I am using under Ubuntu 22.04. It is assuming that wherever we have not provided any value in case of character arrays, it assumes it is null character. Okay, so let us check it by rerunning it. It does again the same thing. So I repeat, it assumes null character in case of character arrays if we do not provide any value. Here I have declared an array of characters of size 10. So it occupies 10 bytes in memory. First location I have initialized with capital A. You can see here its ASCII code is 65. Next location I have skipped. After that I have initialized the next location with capital B. Its ASCII code is 66. And following locations I have skipped, so it should fill them uh, by some arbitrary character or random character. Then ninth location, that is index number 8, I have initialized it with null character, and the last one I have initialized with capital Z. So now what does this do is the C out statement should print right from the first location, that is capital A, up to and including not including the index number 8, that is null character. Okay, so let's see what does it do with the uninitialized locations. So let me start debugging. So it executes, and let me move it a bit further on the right hand side, and then now you can see here these two locations I initialized. So capital A, first location. Next location, it was supposed to be arbitrary. So Visual C++ 2022 compiler assumes this character. It is one of the block characters. Its ASCII code is supposed to be greater than 127. The next location, I initialize it with the capital B, so it has printed capital B. And let's count 1, 2, 3, 4, 5, 6, 7, and 8. 8 characters it has printed. So 0 through 9, you can say 0 through 7, you can say. And eighth look index number 8 is null character. So it prints nothing. So it starts printing from the first character and it stops printing it when it encounters a null character in memory. If you happen to develop your own compiler of C++, you can assume any character, any byte value in place of those locations, those locations which have not been initialized. Here I am using Turbo C++ 3.0, which was released in 1992, and here I have declared an array of characters of size 10. First location I have initialized with the capital A, so its ASCII code is 65. Next location I have skipped, and after that I have initialized the next location by capital B, which has the ASCII code of 66, and all following locations I have skipped. So let the compiler fill with arbitrary values, and ninth location, that is index number 8, I have used null character. So this C out line must start printing from capital A, and you should keep on printing until it encounters null character in memory. So let's see what does it do. So let me execute it by typing Control F9. It has printed something. So let me check what it has done. Now you can see here in case of a C++ version, in Turbo C it was printing A followed by hard character and then capital B, and then it stopped. Here it has printed capital A, and it has assumed that it has nothing else to be printed. It means it might have assumed null character in place of a random character. So just to double check, let me re-execute it. Now let me check. Now again it has printed only capital A. It means C++ version of Turbo C++ 3.0, whenever you leave something uninitialized, it is being assumed as a null character. So even B was there, but it is not being printed. Okay. So if you happen to design your own C++ compiler, you may assume whatever you want to if some location is not initialized. In next video, we will study arrays of higher dimensions. That is all in this video. Thanks for watching.